casually watching a video on YouTube on a computer more powerful than anything humanity could build a few decades ago. This progress and all the wonderful machines you take for granted are built on a few rare and precious materials with names like terbium, neodymium, or tantalum.
Neodymium. I have a relationship with that element because I was going to do my honours here, if you know what that is, in physics over at Otago in New Zealand, and we were going to look at this fucking annoying metal, rare earth metal it's called, even though it's not fucking rare, and we were going to see if it had some cool applications for quantum computing, and more specifically like the stuff that connects quantum computers, and for stuff that you could one day call a quantum internet. But this shitty little material was annoyed the fuck out of me. It's not that rare. It's just sort of it's very dispersed, this stuff, and that's why we tend to call it rare. Anyway.
Getting these rare materials from the ground into your devices is ugly. The mining industry is responsible for air and water pollution and the destruction of entire landscapes. Dangerous chemicals like cyanide, sulfuric acid or chlorine are used to extract the resources, harming biodiversity, workers and locals. And rare resources are also political tools when countries restrict access to them to get their way. But what if we could replace the mining industry on Earth with a clean process that can't harm anyone? Well, we can.
Speaking of something that can't harm anyone, you should come get my new kind of VPN, a post-quantum VPN that can protect you from quantum computers, and no one will ever be able to harm you again. Don't quote me on that. That's not an official statement. But yeah, come get it. I built this. It's got post-quantum cryptographic algorithms in it, and the beta is out. It looks just like this. And it's got a trial. You can get 30 days free. So please come help me, support the YouTube. Trying to get us all to Venus. I want to colonize Venus one day. So yeah, join the club. Anyway, let's get back into the video.
All we need to do is look up. Asteroids are millions of trillions of tons of rocks, metals and ice, leftovers from the cloud that became the planets 4.5 billion years ago. They can be as small as a meter or protoplanets the size of entire countries. Most of them are concentrated in the asteroid belt and the Kuiper belt, while hundreds of thousands more do their own thing between the planets. As space travel is becoming more feasible, scientists and economists have begun looking at the resources found in these asteroids. Even relatively small metallic asteroids may contain trillions worth of industrial and precious metals like platinum. And bigger asteroids like 16 Psyche could contain enough iron nickel to cover the world's metal needs for millions of years. At current market price.
Speaking of that specific asteroid, I believe that's the one where NASA is about to send a probe to, which is a $250 million. No, it was even more than that, wasn't it? Was it like a multi-quadrillion dollar? NASA will launch Psyche mission to explore asteroid worth more than the global economy. 10,000 quadrillion. That's insane. So when is it being launched? Launch in 2023. October 10th. That's going to be pretty cool. The Psyche team. They're going to launch it and be like, psych.
That's the wrong number.
The rare raw materials alone would be worth quadrillions of dollars. Well, not really, but technically. For example, there are more than 20 million tons of gold in the ocean's water, worth roughly $750 trillion US.
Sorry, BRB, I'm going to make a boat. Going to create a big magnet, and I'm going to go get this gold. So I'll see you guys tomorrow. That's going to be the end of the stream today.
But filtering out the gold would be so expensive that you'd lose money selling it. Right.
Challenge accepted.
Now, asteroid mining has exactly this problem. It's too expensive to replace mining on Earth. Billions of dollars worth of valuable resources in space are worthless if it costs trillions to get them. What makes it so hard? The principles behind mining an asteroid are simple. The basic idea is to choose an asteroid, move it to a place where it's easy to process, and then take it apart to turn into useful products. Unfortunately, all of this collides with fundamental problems humans have yet to solve. Going to space is expensive. It costs...
It's actually, I don't think there's any fundamental problems, right? I think the real issues are, in principle, all solvable. The problems are that all the tech required to do all this doesn't exist. So you're going to have to innovate at every step. Trying to create a company that innovates like 100 different things all at once, that doesn't really happen. So that's kind of the problem. We need there needs to be levels to this where we keep innovating and different companies keep innovating. So it's going to take a little while. However, we could leapfrog that. I think SpaceX could do this very soon. I'm kind of optimistic this could happen within the next 10 years. And I've seen some startups trying to actually that are eyeing this off now.
Thousands of dollars in rocket fuel for each kilogram just to reach a low Earth orbit. Going further out into deep space costs thousands more. We need cheaper space travel to make asteroid mining profitable. One solution is to...
It would be a space industry, essentially. It's a whole sort of separate industry.
Switch from classical rockets to
What's up, Will?
electric spaceships. We already use electrical rocket engines for many of the space probes on science missions. In principle, we only need to build bigger ones. While electrical engines are not powerful enough to fly to space, they require only a tiny amount of fuel to go very far once they're in space. This means we don't need to spend a lot of money on fuel, only to transport fuel into space.
And, you could imagine with Elon running both Tesla and SpaceX, that's going to be a pretty solvable problem for the SpaceX, right? With all the innovations coming through in electric stuff. Yes, you're going to argue that's not the same as rocket electric engines, but look, I would wager a bet that probably, favorites to be able to do something like this.
This doesn't solve the whole cost problem, but it makes it easier to start our first mission. Now that we have an electric asteroid mining spaceship, we need to find the right asteroid and get it there. We've already successfully visited...
Equity pass. Yeah, give me just 0.5% equity, and if we get one of those quadrillion-dollar asteroids, you're still speaking like millions of dollars.
Visited asteroids with space probes and even collected samples. Still, to make it easier and cheaper, our first targets will probably be near-Earth asteroids. Asteroids that orbit, well, near Earth. After a few months of travel, our spaceship finally arrives at our asteroid. Weirdly formed, littered with small impact craters, it hasn't changed much for billions of years. The first thing that needs to be done is to secure the asteroid and stop it from spinning. There are multiple ways to do this, like
Man, this would be so hard.
vaporizing material
You have a good day, Nick.
with a laser or stopping the rotation with thrusters. Once we have a stable asteroid, we need to wait. Orbital mechanics are complicated, but if you push something in the right direction at exactly the right moment, you can move very big things with very little force. So, we wait for exactly the right moment. Our ship fires its thrusters and nudges the asteroid into a trajectory that takes it near our moon. The moon is useful because we can borrow its gravitational pull to put the asteroid in a stable orbit around Earth, which saves even more fuel. Again, the trip takes months. But all the time since our ship was launched has not been wasted.
It all sounds fairly reasonable, and I'm sure we can do all of this.
The first space mining and processing equipment has been installed in orbit and is now carefully moving towards the asteroid. The processor works very differently than on Earth. Giant mirrors focus sunlight and heat up asteroid rock to boil out the gases. Grinders break up the dried rocks into gravel and dust, and centrifuges separate dense from light elements. Even if we only extract zero...
So obviously that bit is, this whole process, lots of engineering. This bit's quite interesting. Did you say large mirrors?
Mirrors focus sunlight and heat up asteroid rock to boil out the gases. Grinders break up the dried rock.
Sure, I surely would need a bit more than just some large mirrors. Like, obviously you can, get quite a bit of energy out of that, but...
Rocks into gravel and dust, and centrifuges separate dense from light elements.
Maybe if you got electric engines and, you're funneling some of the energy. Because, some of these asteroids, right? It's got all kinds of hard elements you're trying to get.
Even if we only extract 0.01% of the asteroid's mass in precious metals, this is still several times more than you'd get from the same amount of ore on the ground. But what now? How do we get our precious metals safely back to ground? There are a few ways, like loading it into reusable rockets that return to Earth from space.
I think once we do this for the first time, it might open like the floodgates to space travel. I think if a company can manage to do this somehow, I think there'll be a huge boom and things will change rapidly. Getting to this point might be really hard because think about it. As soon as someone demonstrates or even gets close maybe, but I think until someone demonstrates just how much value can be brought in, they might have to regulate this as well somehow if someone does manage this because it's going to make their company worth a lot of money very quickly. I think if someone can do this, companies will realize, the big companies in the world, okay, shit, let's do this. And then space travel, exploration will expand rapidly. So that'll be an exciting time to be alive. And hopefully This doesn't take too much longer from where we are. Maybe 20 years, maybe 10 years. And then at that point, there might be an explosion. So that's kind of exciting to think about.
Or if our processor contains 3D printers...
I didn't really explain why, because, you know, investors, people who have the money will be like, hey, we can go make some money now. Do it. You know, they form companies just like Jeff Bezos did with Blue Origin because he saw what Elon was doing. He's like, hey, give me that. Do that. Anyway.
We can print a faster and cheaper delivery system. Heat-shielded capsules filled with gas bubbles. These can just be dropped into the oceans where ships tow them away. This could be the starting point of humanity's first real steps towards colonizing the solar system. As our infrastructure and...
Just launching these little mini asteroids back at Earth, like calculated, so they land in certain places. There would be some uncertainty, right? So I'm just picturing some sci-fi story you write about, you know, some cowboys, you know, tracking asteroids from this quadrillion-dollar company, and they launch, you know, these little gold asteroids. It's like futuristic gold mining, right? Where you track these little asteroids that this company is launching back at Earth, and then the first one to get it, you know, gets a little chip of the gold off or something. That would be a fun story, no?
Experience grows, our missions get more and more sophisticated. Parts and fuel produced on asteroids don't have to be launched from Earth at all. The first mining operation makes the second one easier, and so on. While the space industry grows and precious materials become cheaper, eventually we could stop mining on Earth. Even the idea...
I've really never considered that to that degree. Like, why did I never... But that wouldn't really matter too much. Sure, we would stop mining to the degree of finding, like, expensive materials, but unless we switched over to sustainable energy, we're still going to have to keep mining fossil fuels. But no more mining metals and stuff like that would be great. I wonder, you know, it's interesting to think
about.
about.
Of toxic mining down here might become something weird and anachronistic, like having an open fire in your living room. Landscapes ravaged by pollution will heal, while the technological wonders we're used to get cheaper and less toxic to make. None of this is science fiction. We don't need fancy materials or new physics to make asteroid mining happen. We could start building this future today.
Maybe everyone in the future, in like 50 years, is going to be walking around with like gold cars and golden everything. That'd be pretty cool.
All we need is an initial push.
Another great video. I really enjoyed that. What'd you guys think? I thought that was a pretty fun. I like how close that one is to, you know, what we're currently capable of. It's exciting. It's exciting.